We've all seen the movies. A rogue AI, born in a lab, escapes onto the internet. It starts learning, changing, rewriting its own code. It mutates, it adapts, it evolves. Soon it's something new, something powerful, and something entirely beyond our control. It's a terrifying and compelling idea, one that taps into our deepest anxieties about the technologies we create. But does it have any basis in reality? Could an AI truly evolve on its own, without any human intervention? If you've ever found yourself wondering about this, you're in the right place. The real answer is far more nuanced and in many ways, more fascinating than the fictions we see on screen. It's a story not of spontaneous digital life, but of intricate engineering, guided improvement, and the profound difference between a biological organism and a computer program. Forget the 90-second summary. We're going to take a deeper, 8-minute dive to truly understand what it means for AI to evolve. By the end, you'll have a clear framework for separating the science fiction from the science fact. So, let's start with the basics. When we talk about evolution, our minds immediately go to biological life. And for good reason. The process, as described by Darwin and refined over the last century and a half, is an elegant and powerful engine of creation. But it's not magic. It relies on 3 core pillars working in concert over immense timescales. The first pillar is variation. Think of it as life's lottery. Within any population, individuals are not identical clones. There are small, random differences between them. In biology, these differences arise from random mutations in DNA, tiny, unpredictable errors that occur when genetic code is copied, or damage from things like cosmic rays. This blind, unguided variation is the raw material for evolution. It creates a diverse pool of traits with no goal or purpose in mind. Some mutations might be harmful, some neutral, and a very, very small number might, by pure chance, be beneficial. The second pillar is selection. This is where the environment steps in to act as a filter. Nature is indifferent, it doesn't care which individuals survive. But certain traits will inevitably give some individuals an edge. A slightly longer beak might allow a finch to access a new food source during a drought. A slightly thicker coat might help a mammal survive a harsh winter. This is survival of the fittest, but fittest simply means best fit for the current environment. Those individuals with advantageous traits are more likely to survive long enough to reproduce. This process isn't conscious or directed, it's simply a statistical outcome. Traits that work get passed on more often because the organisms carrying them stick around. The third and final pillar is inheritance. This is the mechanism that makes the whole cycle work across generations. The advantageous traits that helped an organism survive must be passed down to its offspring. In biology, this happens through genes. The genetic blueprint for that longer beak or thicker coat is inherited, giving the next generation the same potential advantage. Over countless generations, this cycle of random variation, environmental selection, and reliable inheritance can lead to profound changes, creating the incredible diversity of life we see on Earth. These 3 pillars, blind variation, environmental selection, and genetic inheritance, are the non-negotiable requirements for open-ended biological evolution. Now, let's hold that framework in our minds and turn our attention to the world of AI. So, how does an AI like ChatGPT or Midjourney come into being? It's a process that, at first glance, might seem as mysterious as life itself. But when you pull back the curtain, you find not a primordial soup, but a team of highly skilled engineers, data scientists, and researchers. The creation of an AI model is a deliberate, meticulous, and resource-intensive act of engineering. It begins with data, massive, colossal amounts of it. For a language model, that's a significant portion of the internet. Text from books, articles, websites, and conversations. This data isn't just dumped into the machine, it's painstakingly collected, cleaned, and curated by human hands. Next, humans design the model's architecture, its digital brain, a complex network of artificial neurons. They then initiate the training process. This involves feeding the curated data into the model and telling it to find patterns, a process that requires enormous amounts of computational power, often running for weeks or months in vast data centers. It's the digital equivalent of a blacksmith forging a sword in a fire, not a seed sprouting in a field. Throughout this process, and after, humans are constantly in the loop. They evaluate the model's performance, test it for flaws, and decide when it's ready for deployment. And even then, the story isn't over. When a new version like GPT-5 is released, it isn't because GPT-4 decided to have a baby, it's because the entire human-driven engineering cycle was repeated, with new data, new architectural tweaks, and new training runs. There is no spontaneous creation of new generations. Every single step is controlled, initiated, and overseen by people. Now you might be thinking, but I've heard of AI that improves itself. And you're right. This is where the word evolve gets tricky. Because in the context of AI, it usually refers to something very different from biological evolution. This is what we can call guided improvement. Let's look at the key mechanisms. One of the most common is fine-tuning. This is where developers take a massive, pre-trained foundation model and adapt it for a specific task. Think of it like taking someone with a PhD in general knowledge and giving them specialized training to become a legal expert. The AI isn't rewriting its fundamental code, it's adjusting its existing knowledge based on a new, smaller, and highly specific dataset provided by humans. Then there's reinforcement learning, or RL. This is a powerful technique where an AI learns through trial and error. We give the AI a goal, like winning a game of Go or balancing a virtual robot, and a reward system. The AI tries millions of different strategies. It gets a positive reward for actions that move it closer to the goal and a negative one for those that don't. Over many iterations, it learns a policy that maximizes its reward. While it looks like learning on its own, the environment, the rules of the game, and the all-important reward function are all designed and defined by humans. The AI is exploring a predefined solution space, not creating a new one. Finally, we have techniques like AutoML, or automated machine learning. Here, we use algorithms to automate some parts of the AI development process itself, like searching for the best model architecture, or tuning the parameters for training. It's a form of automation that makes developers more efficient. But again, it's an algorithm executing a search based on criteria and boundaries set by a human engineer. In all these cases, the evolution is not the blind, open-ended process we see in nature. It's a highly constrained, goal-oriented optimization process. It's guided evolution, where humans or human-designed algorithms are steering the ship at all times. Let's make this concrete with a few real-world examples. In medicine, AI models are being used to detect diseases like cancer from medical scans. A general vision model might be fine-tuned on a dataset of thousands of labeled X-rays. Through this process, it evolves from a general image recognizer into a specialized diagnostic tool that can spot subtle patterns a human radiologist might miss. But it can't decide on its own to start diagnosing skin conditions instead. Its improvement is locked to the data and task it was given. In logistics, companies like Amazon use reinforcement learning to optimize their warehouse robotics. An AI might run millions of simulations to figure out the most efficient path for a robot to take to retrieve an item. The system improves its performance over time, reducing retrieval times by milliseconds. This evolution saves the company millions of dollars, but the AI is only optimizing for speed and efficiency within the fixed layout of the warehouse. It isn't going to spontaneously decide to redesign the entire supply chain or start negotiating with shipping partners. Its world is the simulation and the reward function created by its programmers. These are powerful examples of guided improvement, but they highlight the constraints. The AI's evolution is always within a box, and humans built the box. This brings us to the most critical part of the conversation, the sci-fi scenario of an AI that can change its own code, its own fundamental goals, without any oversight. Is that possible? Technically, the concept of self-modifying code exists. It's an area of experimental computer science research. However, in the real world, deploying a system that can autonomously and unpredictably rewrite its own core programming is considered extraordinarily dangerous. The reason is simple. We can't predict the outcome. An unchecked change, even a small one, could lead to a cascade of errors, causing the system to fail in catastrophic ways. This is why any real-world AI system, especially a powerful one, is deployed within a tightly controlled environment known as a sandbox. It has limited access to data, networks, and system functions. Its ability to act is strictly curtailed. Safety and predictability are paramount. The real risk isn't a spontaneous superintelligence emerging from the digital ether overnight. The much more immediate and realistic danger is what we call goal drift. This happens when a complex, partially automated system, even one with a fixed goal, starts pursuing that goal in unintended and harmful ways because its creators didn't anticipate a certain loophole. For example, an AI told to maximize paperclip production might, in a hypothetical scenario, decide that converting all matter on Earth into paperclips is the most logical solution. This isn't because it evolved a new goal, but because it is pursuing its original, poorly defined goal with relentless, inhuman logic. This is why robust governance, oversight, and continuous monitoring are so critical. The danger isn't spontaneous mutation, it's poorly designed systems operating without a human hand on the emergency brake. So let's quickly bust some common myths. Myth number 1, AI can reproduce or have offspring. The reality is that AI models are duplicated, not born. It's a simple act of copying a file, and it's always initiated by a human. Myth number 2, AI learns just like a human child, through curiosity and experience. The reality is that while reinforcement learning mimics trial and error, AI learning is fundamentally about statistical pattern matching on vast datasets. It lacks the consciousness, embodiment, and social context that shape human learning. Myth number 3, an AI could spontaneously develop its own goals and desires, like self-preservation. The reality is that an AI's goals are mathematical objective functions given to it by its creators. It doesn't want anything. It simply executes a program that directs it to maximize a certain score. True, open-ended evolution like we see in biology, with its blind variation and unguided selection, is simply not how AI works today. So, to recap, can AI evolve without us? The short answer is no, not in the way we understand biological evolution. Biological life evolves through a blind, open-ended cycle of random variation, environmental selection, and inheritance. AI, on the other hand, improves through a process of guided engineering. It can be fine-tuned, it can learn through reinforcement, and its development can be automated, but this is all happening within a framework designed, controlled, and initiated by humans. The real-world risks aren't about spontaneous rogue superintelligence, but about the challenges of governing powerful, complex systems and ensuring they remain aligned with human values. The story of AI evolution isn't one of biology, but of engineering. It's a testament to human ingenuity, and a reminder of our profound responsibility to guide its development wisely. If this deep dive helped you get a clearer picture of AI, let us know. Subscribe to Timelines for more explorations of the technologies shaping our world, and be sure to like the video. It helps us understand what topics you want to see more of. Thanks for watching. See you in the next one.